overkill of outside lights for my home. The plan is you enter on sensor 1, which then switches on 4 10-watt LED lights. If you go into the house, they switch off. If you come out the house, they switch on. And if you go into the garden, they either switch off if you've come out the house, or they switch on 4 10-watt LEDs out, off this sensor, out. That was the plan. Run by an Arduino and a little bit of electronics, which you'll see as we go on. It didn't go the way I planned. So let's go into detail and find out what actually happened and how I ended up. It's just a standard PIR which you connect onto the Arduino. Nothing fancy. Got a couple, one for either end. I'm going to mount them into the Tic Tac case, which is the sweets. Plus side is I've had to eat the sweets to empty it. So we're going to fit that in there, and I'll show you the next bit. You can see on these I've got a couple of sensors here that I used. I've removed the PIR. It wouldn't go in without removing it, and also it's for where I wanted it. So I've attached it with 3 wires into the back of a 3.5 jack socket, basically. One of the jack plugs, one of these. It's the case that goes around the outside. I've binned the other bits, but unfortunately I didn't have a plastic one. I only had a metal one. So the PIR just fitted nicely in the back of it. So that was a success, and it also fits very tightly in there. The reason for putting it into this, if you like, into this case, was because I wanted it to fit between the wall and the drain pipe, the down drain pipe. So this is mounted in place. As you can see, this is the 3.5 jack, and it's all mounted in there. A treat, really. It fits very, very well. The 2 sensors, the 2 trims were put down to minimum. Soldered the 3 wires onto the pins, and out it came, straight on then to the Arduino. Sketch and the Arduino. The sketch, I can't write sketches. I copy sketches, I amend sketches from other people, but for me to actually do one, this is probably the first one I've ever done. I didn't feel confident with it at all. I believed it worked, but it wasn't the way or as efficient as I wanted it to. So what I decided, I would ask the Arduino forum. So I put the question on, something on the lines of trying to do a over-the-top overkill house lighting, looking for a sketch. Could anybody point me in the right direction? And everybody says, oh, that's easy. Well, it's easy if you know, and I didn't know. So anyway, the long and short of it, a guy called Dave in NJ was his handle on the thing, put some links onto YouTube. So I went onto these links, and they was for stairs. Stairs? Why do I need stair lights? Anyway, I sort of dismissed it. And then 2 or 3 days later, I suddenly thought, well, hang on. If I did 10 1-metre lengths of strip light rather than 4 10-watt LEDs, that would look quite effective. So I persevered, looked at his sketch. I did email him because I wanted to know whether or not it actually switched off on the PIR rather than run on the timer. I could understand that it was running on the timer, but I thought I'd ask the question just in case he'd done it. Anyway, long and short of the story, this is what we did. We changed the whole concept of what I was originally doing, and this is how I put it together. This is the schematic. I'm not taking any credit from this, really. Speedy Signals is Andrew's webpage. Andrew Ongo, I think his surname is. Forgive me, Andrew, if I said it wrong. But it's Speedy Signals, the webpage, anyway. And this is his schematic. I have changed the right hand side of it. As you can see, I've put TIP120s and there's a 1 meter strip of LED there, and basically that's my sketch of it, my part of it. The rest is all Andrew's. Slight error on this bit, but that's, anybody who knows really, that you should be able to spot that anyway. So what do we do? I made it on what I call Vera board, the underside of the circuit board. As you can see, I've used 2 pieces of Vera board, lined the copper trace going that way and the copper trace going this way. I'm showing the underneath first. As you can see, it's not been trimmed, it's just been soldered on. You can see the cuts in the tracks are there, so really there's just 2 holes. The negative rail is running all the way through, and with these TIP120s, the heatsink is attached to the centre pin, which is fantastic for this type of project. This is something that one of the RAF guys showed me many years ago, of using the heatsink as part to solder onto, and for this project it really worked well. I'm not a fan of plugs really, or the, what do they call them, well, the Arduino pins if you like. I'm not a fan of those. I do like it hardwired or soldered, screwed in, whichever way you want to put it. So anyway, 10 channels, negative switching. The two boards are linked via the resistor. So these are the outputs from the shift register. Pin 1, 2, 3, 4, there's 10 anyway. Moving on to the second one, and then a final picture before we get, at this point we're waiting for the shift registers to turn up, so sort of got a bit bored, so I thought I'd take a few photographs. And you can see the solders running through, running nicely. Have turned up and we are now moved a little bit forward. You can see they're now in situ. I was going to actually use an Arduino Pro Mini, but after I'd sort of looked around I thought, I'll tell you what, let's put a Nano on there, because it gives me a chance to have a play around with the lights and reprogram it easy. That was all what I was thinking, and really I want shorter space. I got it in stock, so that's what we did. I also, at this stage, I think it's a buck converter, I think, when it goes down. So there's 12 volts in, and the reason for using the 12 volts down to 5 is that I needed a supply for the sensors. So here we have the negative, so that's basically on the negative rail. This is the new positive rail, or a positive rail, of 5 volts. So negative and 5 volts. Obviously it's a, I'm going to say a communal negative, but it's not really. There's another image. You can see here, this is the hardwire, and the reason I use hardwire is because it's actually sitting on that, and when I mount it in the case I'll actually glue it. So here's the underside. Again, now we've got it trimmed, we've got them trimmed down. Really there's not a lot of solder in there because it's soldered straight onto the pins. That will be the resistor link in there. We've got the negative rail, bit of crossing over here. I actually believe I did the 5 volts onto the Arduino as well in the end. Didn't need to, but I did it anyway. Another top view. Again, it's pretty much the same sort of thing. Here we have 5 pins, if I remember correctly. PIR 1, 2, sensor, I'm going to say at the moment, center, manual override, and that one was for the light sensor, so when it gets dark, photo, something sort of the cell, but we'll show that a bit later. So these are just some images anyway, and you can see how it's come together. So the next step is of course to test it, so let's move on to that. The testing, we've connected the PIR, the sensor line, to the pin, and there as well we've got the yellow wire is the live from the 5 volt, and the white one is the negative to the 5 volt. So that's all looking good, nicely lit up. This is a test bed I've made. All the wires are screwed in for the 10 channels. So let's have just a quick look at the next one. You can see there, all screwed in nicely, running down. Nothing else on there. The elastic band, that's only to hold it to the test bed. And the test bed was basically 30 LEDs, split into 3, which is obviously the 3 for the 12 volt. Just cut the negative track, soldered it onto the other side. The live runs all the way through. And that was it, really. So that's ready to now switch on. So let's have a look and see what happens. I know what happens because I did it, but let's show you what happens. Testing time. Right, the sensors are here at the bottom. This one makes it go to the right. This one should make it go to the left. So let's have a look. And you can see this. There it goes. Runs to the right. It is on for 10 seconds. I do apologise. I could cut it out, but that's really not showing the true timing and everything else. So that's that one. Sensor on the left. It makes the lights run to the left, and it follows along. So the long and short of it is working perfectly, just how I wanted it to. So now we've got to box it all up and get it all looking tidy. In the box, I've used I'm a bit of a radio, or was a radio control freak. So this is a Servo Box, one of the high-tech Servo boxes for anybody who's interested. As you can see, I've now installed it. We've got the hot glue holding the nano. Also, I've cut sockets in holes for the socket there so that the USB will go through. All the LED wires will go through this slot, and the sensors will come through this one. Sounds easy. Another angle of it, you can see the buck converter. I wish I could remember which way around they were, but anyway, buck converter there. Nothing really special. There you go, another angle. All in there, glue, all hot glue, all over the place as usual, and then the top down. And so we're boxed. We're ready to go, or getting closer anyway. With a load of electronics in, we've now got to get the LEDs sorted. This was sort of more of a fluke than anything else. What I've used here is 20mm. It's 20mm right angle plastic. Now, while I say it's a fluke, I've had this in the garage for I don't know how many years, and I had 6 strips, but I needed 5 because they're 2 metre length. So, you know, sometimes you just think these projects are meant to be done because the bits are there. So 2 metre lengths, I needed 5. The beauty of it was, obviously, I was using 1 metre of LEDs. So it was sort of, you could do it modular if you like, and this is how I mounted it on the wall. I was going to mount it with the LEDs underneath, but no disrespect to the Chinese, it might say 3M on the back of that adhesive, but I don't believe it's 3M to save anything. So I decided the safer option was to put it on the side wall. I mounted the plastic, as you can see, with this screw head here, which also just caught the edge of the LEDs, which were waterproof, the silicon type waterproof over the top. This wire here is actually the sensor wire. I decided to run the sensor wires in underneath the, or in the angle, and on the top of it, on the top of the angle, was basically the switch in the negative rail along the top, so it looked a little bit tidier and not so many colours. So we got them all lined up, and we nearly got them straight. So a little bit of a bump there, but we're coming along. What we got there, probably about 2 meters there, and then the other way. So there will be the other 3. A couple of places where it was quite difficult, and obviously this is plastic on plastic, so it. I didn't try and glue it to the bit. I just literally screwed it up. There isn't a lot of weight in it. It's more awkward than anything else. So that's the run. These, The easiest way I found was to actually look at your 2 metre length, drill a hole at 1 metre, cut the negative track at 1 metre, and then bring your, well, let's say it's from pin 1 or from the trigger, the TIP120 number 1, solder that onto the negative track further down from where you've cut, and then from the other one further down, so you've got the switching of the two, leaving the live running through. Obviously when you've got to put your next 2 metre section up, you had to join the live, but that worked quite well, and you had to cut the silicon off to reveal the circuit board, if you like, to solder it onto. So I've covered it again with silicon, and most of the wall and the screw on silicon and hot glue just seem to be not friends with me at all. But anyway, then we did the photoresistor. That was mounted into a biro pen, silicon the top to seal it up, bit of shrink wrap, shrink tubing, and all the wires go through a hole behind this piece of trunking. So you've got 10 wires running out, 3 sensors coming back in, plus the all ending up inside the house. Outside the I knew the cabinet was there, and we just kept drilling straight through until we come through. The cabinet is right against the wall, to be fair, so it wasn't a problem. Bringing the wires down into the unit, which then became a bird's nest, as they always do when you've got a lot of wires coming in loose. I did try and keep them as tight as possible. You can see all the 10 wires there are, does that work? Yeah, all soldered in. And all the yellow wires are sensor wires. This yellow switch, that's the override switch if you ever want to put it on, which obviously you do for testing one thing or another. USB is nice and easy to get to. The power supply, which gets installed in a minute. So all in all, it's going quite well. A bit awkward, but that was down to where I positioned it. It was like all these things, it seemed a good idea at the time until you try and get your head in there. Or supply, which is a 10 amp power supply. I went for this shape. I think it came from Germany, but I quite liked it. It's nice and tidy, really, and just hooked it up and away we went, really. Just to give you an idea of the position this is in the house, that's where it is in the cupboard, and then we've got a refrigerator, a dryer, so you can see it was quite high up in the top corner, but it worked. It's fine. It's out the way, shut the door, forgot about. This all went very well. There was one area which I really couldn't decide on, and what sensor to put on the back door. I'd used the PIRs. This is the one for the back, so it fitted nicely in there, so that was fine. The one at the front was fine, but the back door, I didn't know if to use the magnetic one like you do for burglar alarms, infrared, or another PIR. But I decided, after messing about, that I would actually try another PIR. And I made this up, and it fitted underneath the windowsill, which was just to the left of the door. So as you came out the door, you would be hit by the PIR. So it was sat under there, and it looked like, well, it sort of doesn't look tidy here, but you can see. Anyway, that didn't work. That one, or this one actually, it just wouldn't work for some unknown reason. Anyway, so I've whipped it out the case and put it into just a tube. This one. In the meantime, you can't really see it because it's pretty tight there. But in the meantime, the one on the back here had dropped off or dropped down because of the Velcro. I just Velcroed it on just to see. And all of a sudden I realised that actually it was being triggered when you came from the back by this one. It worked for the door and it worked for the back, which I was quite surprised about. I didn't expect it to have that range because it's such a narrow beam that purposely, so that the animals don't set it off and keep it nice and tight. So I then redesigned to this one, which was again back to me Tic Tac case, and put the PIR in the end with the original diffuser, I guess, and a piece of plastic tube on it to narrow the beam, and fitted that underneath. That worked, well, it does work really well. I've actually scrapped now the one behind here, so there is actually only 2 sensors, but it's under this piece of windowsill there. I haven't got a picture of that one in situation, but it just sits under there, and it just works brilliant. It really does. So there's only 2 sensors after all, so the third one wasn't used. It was scrapped. More than happy with it. More than happy. So, but that was more a fluke, just the fact that the other one came off the Velcro and it worked. When it's a waffle, you really ought to see these lights working. So this is my take on it working. I'd really like to thank Andrew for his efforts, and also for the guys putting me in the right direction. Very pleased with the lights. This is my first ever video on YouTube. It was all done through a couple of mates who said show us what you've done and show us how you did it. So you can give me the thumbs up. I'm not going to say subscribe, because I don't know whether or not I'll be doing any more. But you can give me the thumbs up if you like it. And just one other thing while we're talking, you may see in the background that just here I've left a 150 watt halogen light on a PIR. You may see it come on next time I come out. It's actually quite amazing how bright these LEDs are. So will it come on? There you go. It's pretty useless. It never comes on at the right time when you're coming out the house, as you might notice. But the long and short of it is, I'm more than happy with the project. Like to thank all the people that put the effort in, and I will list them in the description below. And enjoy the last few seconds of my lights. Outside light, overkill. Thumbs up, everybody.